Hello, and welcome to our third video tutorial. Today we'll be covering some of the basics of characterizing dimension constraints. And there will be two main constraints that we'll be concerned with. The first one will be overall dimension constraints of the bridge, and the second will be local or member constraints. So constraints on how big your members can be. That's equivalent to that box that we have to fit all our members in. So the first thing that you need to do when you start considering the dimensions that your bridge has to satisfy, you go to the rules, and I've just brought up the rules from 2014 just as an example here. You'll be working with the rules from 2015 obviously, but this is a good place to start, especially since the rules will likely be very similar to these ones. Now, as you can see, they've already summarized most of the dimensional constraints for the overall bridge. This is for 2014. They have a site plan characterization, they have an elevation view, and they have a section view of the bridge. And it has limiting dimensions here, here, and here. But the unfortunate thing is, this is actually not to scale, nor is it something that you can actually directly work with. So the first thing that you need to do is take a look at these dimensions, and these are also summarized earlier in the rules. You can clarify those there as well, and then translate them into something that you can use, i.e. an AutoCAD drawing. So I've already gone and taken the liberty, just for the sake of time, to draw up some basic plans. Now here I've duplicated the plan view, the elevation view, and the section view. I've also included a detail that shows some of the dimensions of the box, so that 3 foot by 6 inch by 4 inch box with different orientations, just so I can work with it if I want to. And of course I've included some of the limitations. These dashed lines are the vehicle passageway. Obviously the max length of the bridge is 19 feet. Minimum span length is 17 feet. Minimum clearance is 1 foot 7 inches, and so on and so forth. Of course, looking through the bridge, this would be a region where you can't have anything. This is the vehicle passageway. You must adhere to it. And also this is basically the same thing as here, just a minimum height requirement. So now if you go ahead and get that set up, we can kind of start taking a look at how we can use this. So taking a closer look, I've already kind of gone through, and I'll look at this window here, gone through, and I have just kind of guessed at how many members I'll probably going to be needing in order to span the full length of the river. So just taking some of those boxes that we had at this top right detail and then copying them, and I've included a small overlap of about 1 inch just to account for the overlap due to connections, since you're going to need to overlap your members in order to put a bolt through them at the connections. So always account for overlap, since that you don't want to be butting up members end on end. Overall though, it looks like we're going to be needing 6 members total to span the length of the bridge. And that sounds about right, given the fact that, well, this past year, of course, we had 6 girders along the length of the bridge. And of course we also have legs. I haven't drawn in anything with regard to an overtruss or anything like that. This is just bare bones, so you can get the idea of where to start. So always start with something where you're going to be placing your decking support, which will be here, just along the span length of the bridge. Now, on the topic of decking support, let's take a look at the section view. Now, here we can kind of see, of course, we want our decking support surface to be kind of at this level, more or less. But as far as placement is concerned, I've taken the liberty, again, of going ahead and drawing up just kind of a template for what you might expect to see for, say, a girder part. So here's a girder in cross-section view. Here is the main tube, and this red line is where the load would be applied. Here is the bottom chord of the girder, and then this is either a mini flange or something that could connect up to a tendon or something like that. Now, in terms of placement, you probably noticed these dashed lines earlier. These basically limit where you can actually place your girders, and more specifically, the restrictions on your decking support surfaces. So this big green line right here is pretty much the inside edge of your decking support surface, and this teal line is the outside edge of your decking support surface. Now, according to the rules in 2014, and again, bear with me because this may change this year, but it's quite likely to stay the same since it was also the same 2 years ago. Essentially, what the requirement is that the outside edge, this teal line of the decking support surface, needs to be essentially a minimum distance away from the other outside edge of the decking support surface on the other side of the bridge. Now, what all that amounts to and how I've drawn it here basically correlates to a very simple thing to remember. All you need to do is make sure that this thick teal line is to the left of this dashed teal line, and this thick green line needs to be to the right of this dashed green line here. And of course they're not highlighted on this side, but the opposite would be true. The teal line would be on the inside here, the green line would be on the outside there, and this would be mirrored, so the green would be on the inside there, and so forth. Now, just to give a demonstration, this is technically okay. This is not okay. As you can see, the green is outside of this bound. Anywhere in here is fine. Here is also fine. It's still fine. It's no longer. This is bad. We don't want this. So usually somewhere in this range is okay. So that's probably one of the more confusing rules that you might encounter, especially with regard to the dimensions. So getting a good grasp on how that works is a good idea. So hopefully, if that makes sense, let's take a look at some further dimensionings. Now, let's suppose this is our girder, but we don't want it to just be one member deep. What if we wanted it to be 2 members deep? And I'll just kind of really quickly mirror this down. And let's suppose we wanted our member to look like this, so we had a lot more depth to our bridge. Taking a look at this drawing, here's an example of what that might look like. Now, the issue that you probably notice is that, well, we're actually violating one of our dimensional requirements. That is, we need a minimum clearance of the bridge of 1 foot 7 inches. However, our bridge is dipping below that length. Now, we could just move the whole bridge up, but then we'd be violating this maximum height of 2 foot 4 inches. That is to say, the decking support surface cannot be higher than 2 foot 4 inches. If we violate that height, and then we are no-go, pretty much. So, taking a look at the section view here, here's an example of what I'd be talking about. I've rotated the boxes here, and these blue boxes in section demonstrate essentially where you can fit a particular member. And if you rotate them, you can actually get a significant amount of depth out of the bridge. This teal member is highlighted just to demonstrate that this is an individual member unto itself. Now you can connect the bridge up like this, but you can see, and again, I've highlighted members to show which ones are, the ones in teal are essentially their own separate members. So you can see also I've basically stacked these boxes one on top of the other, end on end, and they all kind of fit together in this nice little pattern. So here's one approach essentially that you might take if you wanted to try to, say, do a quote-unquote stacked bridge. And a stacked bridge is essentially nothing more than just stacking a bunch of boxes on top of each other and then just interlocking the members at these intermediate connections. That's pretty much what we did 2 years ago. Now, unfortunately, it would have been infeasible to do it this most recent year. However, what we did in 2014 was, of course, the overtruss. So, giving you an idea of how that might look like in section first, we have a box, pretty much, that would contain a lateral here, just below the vehicle passageway. And here, on either side, would be boxes. You would draw the boxes first to demonstrate where the girders would go. The girders would give you enough width in order to get out and around these limiting vehicle passageway once again, so that you could fit your tendons on the outside of it. And you can see it's a very close squeeze. This line is basically right on the edge there. So your dimensionings get pretty tight once you start trying to do these things. Now you could change your overlaps depending on what kind of connections you plan to use, but I'm just playing it safe and using 1 inch overlap here. And then of course you'd have your top chords coming in through here, represented by these boxes. Looking at it, what it might look like if you were to, say, put boxes together for an overtruss configuration, you can do something like this, and that gives you more or less the configuration that we had this most recent year. And there's any number of other configurations that you can come up with, but the basic principle is just keeping in mind your dimensional restrictions, that is, these purple limits that I've drawn here already, and then of course making sure that all of your members fit within boxes, and that the boxes essentially connect to each other, and that there's sufficient overlap to ensure that you can put a connection there and then put the members together, essentially. So, this technique, I guess I picked up from Alex Wong, and this was his method. There's a couple other methods that I'll discuss in a later lesson, but for now, go ahead, try to create your own dimensioning file, and then just kind of start playing around with boxes, and then put them in places, and just come up with ideas for now. In the meantime, I'll try to come up with some more lessons, and hopefully we can continue with further plans, so to speak. Okay, I'll talk to you guys later. Good luck. Have a great weekend.